Hello everybody. In this chapter, we are going to see the various types of tools that are used in onboard diagnostics and vehicle diagnostics. The first is tool, the most important tool or mechanism used in onboard diagnostics is OBD 16 pin connector standardized by SAE J1962. Here we go. The onboard diagnostics 16-pin connector standardized as SAE J1962 is mandatory interface. Understand this word very carefully. It is a mandatory interface for diagnostic access in vehicles equipped with OBD systems. It is commonly referred to as a data link connector, acronymed as DLC, and provides universal connection point for diagnostics, emission testing, telematic devices across most vehicles manufactured since 1996. On the right side, you can see the standardized pin connector. It obviously named as a 16 pin connector, as the name itself says. It has 16 types of pins and 16 types of points of interface. Now, connector types and physical connectors. There are two types of J1962 connectors. Now, type A used for 12V systems, typically found in passenger cars and light duty vehicles. Now, type B used for 24 volt systems, generally found in medium and heavy duty vehicles. And the type B connectors have distinctive interrupted groove in the middle. So this is how you differentiate type A and type B. There is a distinctive interrupted groove in the middle to prevent type A male plug from fitting into type B socket, but allowing the reverse. Okay, so both types are female 16 pin 2x8 D-shaped connectors, usually located within 3 feet of the driver, often under the dashboard. This is something I am sure every car driver or car enthusiast would have seen, right under the dashboard, nearing the steer wheel, all behind the panels for easy access. The point is, this onboard diagnostic pin is usually very accessible to the driver. Now, I request all of you to pause the video and see this table very carefully. This table very clearly outlines the pin number, what is the signal that is emitted out of that pin, and what is the description of that signal. For example, 1 manufacturer description, 2 J1850 bus, 3 manufacturer description again. So manufacturer means the OEM description, whoever is manufacturing the vehicle. So I request all of you to pause the video and study this very carefully. Maybe you can take a screenshot, maybe you can take as a print screen, but keep this handy so that you can have a clear-cut idea in case you are a OBD professional to understand what the 16 pins explicitly mean. All right. Now let's go into the further key details. The pin 16 always supplies battery power even when ignition is off. This is one important salient feature. Now coming to the pin 4 and 15 are grounds and must always be present. This is clearly outlined in the tabular column table in the previous slide. Pins 6 and 14 are used for CAN bus communication, the most common protocol in modern vehicles. Pins 2 and 10 are for J1850 protocol, primarily in the older US vehicles. Pins 7 and 5 or 7 and 15 handle ISO 91412 and ISO 14230 protocols. This is common in European and Asian vehicles. And the remaining pins are often reserved for manufacturer specific functions or left unused. Now coming to the supported protocols, the OBD-II interface supports several communication protocols which can be inferred from connected pins. All right, so standards like ISO 16 CAN ISO 15764 uses pin 6 CAN H and pin 14 for CAN L, now a global standard. Now CAN H means CAN high and CAN L means CAN low. Now SAE J1850 pulse width modulation, variable pulse width modulation uses two pins. Bus plus uses pins 2 for bus plus and 10 for bus minus. And ISO 9142, ISO 142304, KWP 200 uses pins 7 and 15. Pin number 7 for K line and pin number 15 for L line. Now the location and the compliance and the connector must be easily accessible, typically under the dashboard, under the driver's seat. All cars and light trucks sold in the US since 1996 are required to have this connector and display OBD-II compliant. So this is important. This is a legal regulation. It has to clearly or emphatically declare that it is the OBD compliant under the hood. Now coming to the usage, the J1962 connector allows the diagnostics tools to read and clear diagnostic trouble codes, which is the very purpose of the pin, of the 16 pin. It also monitors real-time sensor data. It accesses emission-related information and interface with vehicle ECUs for diagnostics and programming. Okay, so I want all of you to read the summary table. In the summary table, I am clearly explaining the feature and type A and what happens in the type B. When it comes to voltage, type A max volt is 12 volt and type B max volt is 24 volt. Typical use cars and light vehicles, and type B is typically used for medium and heavy duty vehicles. And when it comes to groove design, it is a continuous design in type A, and type B it is interrupted. This is something which I touched upon. In the type B there is a distinct groove design, and color making, it is usually a standard color, and when it comes to type B it is a blue color. Compatibility, type B fits A and B, but when it comes to type B, here type A fits only A. Okay, so type B slightly has advantage that it is compatible both for type A and type B male plugs. So in conclusion, the OBD 16 pin J1962 connector is universal diagnostic interface, ensuring compatibility and standardization across the automotive industry for both light and heavy vehicles, and it's standardized pinout and support for multiple protocols make it essential for diagnostics, emission testing, and telematics. Okay, thank you.